Hey, hello viewers, hi there. Today's video we are going to talk about the physics mock exams. So in the disclaimer in this video is that these particular questions was collected by my students, and I asked them, most of them that wrote exam, and they provided these questions. Most of the questions may not actually have options, why some have options. So for the first question we have here, it have options. So let's dive into it. Now we have, if the wavelength of a wave is 3 meter, calculate its wave number. So the first thing I want you to understand that wave number itself is a number of complete cycle over its distance. So if you have a wave that is moving like this, the number of complete cycle of this wave, remember that if you have a transverse wave like this, you have something like this. From here, moving like this, see this particular point, this is a complete cycle. You understand that this is a complete cycle, because when we talk about a cycle here, you have to do that from here to here. It's a half cycle. Then if you add something like this now, it now become a full cycle. So when we talk about this particular thing now, so you really know that from here, if we have another one again and put again, that's one, from here to here is what? One wavelength. Then from here to here is another what? One wavelength. You know that wavelength is what? The distance between a successive what? Crest, or distance between a successive drop. So this particular things illustrates what? Wavelength. Now, what they say you should calculate is wave number. I say that wave number is the number of cycle completed over a what? A distance. Now, what do we have here? So we use K to represent what? Wave number. So wave number has two formulas. The first formula is 1 all over lambda. That's the first formula, where K here stands for wave number and lambda here stands for what? Wavelength. Now the second formula here is K is equals to 2 pi all over lambda. Now whenever you're not dealing with a cycle, this is just for one cycle, you are going to do with this. But whenever you are dealing with radians, which is 2 lambda, you're going to do with this. How do they get this 2 pi? How do they get it? From here, this is 0. Then to this particular point, this is from here is 0. Here is 90 degrees. Then if you reach to this particular point here, here is 180 degrees. Remember, if you are moving from here, half of this is 90 degrees. This edge is what? 180 degrees. Now, this particular place now is 270 degrees. Then from here is what? 360 degrees. Now, some of the questions may not be having this thing in degrees. Some of the questions may have it in radians. That means you're measuring using what? Pi. So if you want to measure this in radians, radians says that 180 degrees is equal to pi. So if I want to replace all these things with pi, that means that here will be pi. The here will be what? Is pi divided by 2, because this is 90, where 180 is pi. So that means that this is what? Pi divided by what? 2. Now reaching this place, we have 180. This is what? Pi. Then for 270, it's going to be what? 3 all over 2 pi. Because 3 times 180 divided by 2 is going to give you what? 270. Then coming to this 360, our 360 what is going to be 2 pi. 2 times 180 will give you 260. So now we are talking about one complete cycle. Remember I said that this K is what? Number of complete cycle over a what? A distance. So this is the complete cycle and this is the lambda. So your formula can be K is equal to 1 over lambda, or K is equal to 2 pi over lambda. You use this one when they're asking you based on what? Cycles in radians. Based on cycles in radians. And with this, since we already know the basics of this, let's answer the question on the board. Now, looking at the question we have, so this is something. Look at the question we have. We have that A is equal to 1 pi over 3 and this thing. Before we that, let's solve. So, which formula are we going to use? Since all of them is in radians, that means we are using K is equal to what? 2 pi over lambda. So K is equal to, what is our lambda here? Lambda given is 3 meter. So we now have that K is equal to 2 pi all over 3. So our answer is K is equal to 2 pi all over 3. So where is our answer? Our answer is this, which is C. You understand? So remember, if the question was just not given to you in pi, if you just come and you solve questions like this thing, what is this, and calculate its wavelength, and all these things was not in pi, that means your answer will not be K is equal to what? 1 all over what? Lambda, where lambda is equal to what? 3. You know, so that K is equal to what? 1 over 3. So now let's head over to the number 2 question. Okay, this is number 2. The number 2 question is on AC circuit. Now, let's address this question. At resonance, the phase angle AC circuit is A 90 degrees, B 60 degrees, C 0 degrees, and D 180 degrees. Now, first, the question was on resonance and start resonance of what? AC. So, first thing you have to have in mind is that before resonance will occur, there are some conditions that can give rise to resonance. What are those conditions? Condition number 1 is that the capacitive reactance will be equal to the what? The inductive reactance, or the inductive reactance will be equal to capacitive reactance. So what does this mean? If we want to represent capacitive reactance, we use what we call, this is a reactance. That's the sign of a reactance. If it is for inductive reactance, we have XL. This L is for inductor. Then we have XC. Then this one is for what? Capacitive was reactance. You know, the major things they do in AC is that they oppose current flow. So now, if they oppose, that's XL is equal to FC. Then if they are equal, what they're going to do is that they are going to be equal in magnitude, but opposite in phase. These are the major things that happen here. So equal in magnitude, that's the size of this inductive reactance will be equal to the size of the capacitive reactance. If they are equal in magnitude, what does magnitude mean? If they are 30 and this one is going to be what? 30, that means they are equal in magnitude. Then their phase angle will be what? Will be opposite. If their phase angles is equal opposite, you remember that in XL, your voltage is leading while your current is lagging. Now here, your current is leading while your voltage is. So if you turn it upside down like this, the two of them will cancel out each other. Their phase will not be 0. Sorry if you don't understand my explanation on the other one about leading and this is lagging. So this is just a short video, but let me show you something. Now in phase has to do with position of a particular thing, either in crest or in trough or even at the intermediate. So I've showed you that using of phase here, whether this is 2 pi or something like that, whether in number 1 question. If I'm not watching number 1, you can go back and check it. Now, if you have this now, this phase now, there's something we call lagging and leading. The first one now is the one that started first. This one will be leading. The second one that started after this number 1 is the one that will be what? Lagging. So for this particular lesson now, this one is leading by who? By 90 degrees. While this one is lagging by 90 degrees. Leading is the person that came first. Lagging is someone that is following at the back. That's this now to understand. So I told you that in XL, the voltage was leading and the current was lagging. For here, the voltage was leading and the current was leading and the voltage was lagging. Those are the major things. So if they are like that, your XL will be equal to what? FC, and your phase angle becomes 0 degrees. That's the first condition. The second condition is that they were going to give rise to a frequency, and the frequency is now going to be equal to 1 all over 2 pi square root of LC. this is the distance. So this is the resonance frequency. This is the resonance frequency. So it's going to give rise to this type of frequency when is at what? Resonance. Now the third condition is that your impedance will be minimal. Your impedance will be minimal. It's not going to just be Z is equal to R. Remember, before that, this was actually gotten from RLC circuit. RLC circuit is a circuit that contains resistors, inductors, and capacitors. And AC that contains resistors, inductors, and capacitors. So if these ones equal and give out 0, what do you think your impedance will be? Remember, your impedance was Z is equal to square root of R squared plus X squared. Remember, where your X is equal to XL minus XC. That's what this thing is. So XL minus XC. So if I replace this thing and put inside there, it's going to be Z is equals to square root of R squared plus XL minus XC all squared. Now if you put it like this is what it's going to now be. So now if these two things equal each other, that means that 30, I use 30 as my example. So 30 minus 30 will be equal to 0. So you now have Z is equals to R squared plus 0. At the end of the day, you now see that Z is equals to square root of R squared. Then this and this will cancel out to have Z is equal to just R. Have you seen it now? So here in number 3 condition, your impedance. Why I'm actually explaining this in like this, so that whenever you see a question relating to this, you will not fail it. This is just a mock exam, but it can also be your main exam question. So listen, so you can actually get the point. So your impedance will be minimum and it's going to be equal to your resistance. So this is then going to be like something we call purely resistance circuit. You understand? AC circuit. That's what it's going to be. Now there's a fourth condition. The fourth condition is that number 4 is that your power factor will be unity. Your power factor will be what? Unity. You understand? Sometimes they will also ask you a question on the power factor is what? The power factor will be 1. That's what unity means here. So power factor is unity because your phase angle is 0. Once your phase angle is 0, that means your power factor is what? Is unity. So your power factor is what? Unity. Now with all this explanation, let's go back to this question. See, as a resonance, the phase angle in an AC circuit is dash. The phase angle of an AC circuit. I should struggle with this. You see that our answer is probably what? 0 degrees. It must be at what? 0 degrees. I've actually showed you what in number 1 factor and in this one. So those are the major things you have to have in mind. So let's go to number 3 question.